right, this is number 3 on your homework tonight, or for this weekend. 3.3 homework. This is number 3 on your 3.3 homework. Okay, so it says, find the point of intersection for two lines by looking at the table. Fill in the table values for each of the linear functions, then circle the point of intersection of the two lines in each table. So number 3, they give you two equations, boom, 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 boom. They give you f of x, g of x. And they give you a table that looks like this. You have to fill in. So now you're substituting in the x values to figure out f of x. So if x is 1, substitute 1 in for x. 3 times 1 is 3, minus 4, negative 1. Now you can keep substituting in, or you can go, I know that my slope is 3, so I'm adding 3 each time. So then this would be negative 1 plus 3, because that's my slope, is 2. Then I can add another 3, because that's what my slope is. That's the change. That's the rate of change each time. And then that gives me 5, plus 3 again, gives me 8, plus 3 again, gives me 11. Ta-da! Hopefully that's right. And it's not right. That's not, okay. 3, did I write this down right? F of x equals 3x minus 4. I'm about to have a disagreement with your book. That's not good. So let's see, f of x, so I'm substituting in 1. So f of 1 equals 3 times 1 minus 4. 3 times 1 is 3, minus 4 is negative 4. And then you would just add 3 each time. I got negative 2 here. Your book is or actually you don't have the book. My book? The book. The book is incorrect. That's annoying. Okay, well, I'm right, they're wrong. Now I'm going to test this out though and make sure I'm not losing my mind. So let's do f of 2. Substitute in 2 for x. You see this? Oh yeah. 3 times 2 is 6, minus 4 equals 2. No, I'm good. All right. So that's your table for number 1, or for the first part of number 1. Do this in purple. So same idea. I'm going to substitute 1 in for x. Negative 2 times 1 is negative 2. Negative 2 times 1 is negative 2. Plus 6, 4. And then my slope is negative 2. So I'm subtracting 2 each time. So that'd be 4 minus 2 is 2. 2 minus 2 is 0. 0 minus 2 is negative 2. Negative 2 minus 2 is negative 4. Okay. Oh, okay. Good. They still intersect. So they intersect right here. They both have the same point. They both have 2, 2. So that would be their point of intersection. Because both lines would go through that point on a graph. All right. So that's number 3. Let's pause. Play pause. All right, number 2. I went backwards. Sorry. So number 2, they don't give you any values in the table. That's okay. If I were you, I would just keep it simple. So this is what they give you, right? They give you 2 equations and they give you blank tables. All right. Well, I would just fill in 0, 1, 2, 3. So then substitute in. Or you should know, just given the equation, this is in slope-intercept form. Y equals mx plus b. Slope, y-intercept. Slope, y-intercept. If you ever see just an X, there's an invisible 1 there, right? You know this, maybe? There's an invisible 1 in front of the X. So if I had X plus 5, there's an invisible 1 right there. We just don't write it because 1 times X is just X. There is an invisible 1 there. Anyway, so slope and then y-intercept. So your y-intercept is 2. Let's prove it. Substitute in 0 for x. So that would be 0 plus 2 is 2. There you go. Ooh, bad 2. That's 2. All right, and then my slope is just 1, so I'm going up by 1 each time. So this would be 3, 4, 5. I'm just adding 1 each time. 2, 3, 4. Yeah. Or you can substitute it in. X is 1. 1 plus 2 is 3. 2 plus 2. 2 plus 2 is 4. 3 plus 2 is 5. Okay, there's that one. And then over here, you can also just do the same thing, 0, 1, 2, 3. And then, so this one doesn't have a y-intercept written, which means it's just 0. Because it's just redundant to write plus 0, so they leave it off. So that means your y-intercept is going to be 0. We can prove it. Substitute in 0 for x. 2 times 0 is 0. 2 times 1 is 2. Now we're just multiplying by 2 each time. Sorry, no, we're not hello. We're adding 2 each time. So then 2 times 2 is 4, and then you would add 2 again. You get 6, and then 8, and then 10, and then 12, and then 14, and then 16, and so on and so forth. Okay. So do they have a point that's the same? Where do they intersect? What point do they have in common? So your intersection point is 2, 4. If you were to graph these, they would both lines would go through this point. All right. Okay, this is number 14. Number 14. You have to state the domain, range, max, minimum, and any intercepts. Okay. Notice that this, I made it really big. Oh, it doesn't look that big. This is not filled in. It should be like that. Okay. This is a hole. We'll get back to that. Actually, what are we going to do first? Okay, well, we'll do the domain. So remember, this is looking at the x values. So there's an arrow going this way. Oh, this is not cool. Because they don't tell you that it continues forever that way. Oh no, I read it wrong. They are being cool about it. My bad. I was looking at the wrong answer. Sorry. Woo. Almost had to okay, never mind. We're good. We're good. Domain. So you're looking at x values, all right? So do we have any negative x values on this graph? No. All right, the first one we have is x equals 0. So our domain is 0. But why is this not a bracket? Because there's a hole. There's a hole there, so that means it's not really part of our interval. It's just we're getting as close to 0 as possible, but we're not actually hitting 0. It's there's a hole, okay? So that's why you have to use a parenthesis. If this dot was filled in, if it was just a regular point on a graph, then we would use a bracket. But it's not. There's a hole, so it's a parenthesis, okay? Let me say that one more time. We're using a parenthesis because this is a hole on the graph. That's actually not part of our interval. We're just getting as close to 0 as we can, but it's not actually on there. If this was filled in, if this was a regular point, it would be a bracket, but it's not. Okay, and then we're going forever this way. So we're going to infinity. My x values continue forever this way. So this is like 1, 2, 3, 4, 5, and then we continue on forever, forever, and ever and ever. Okay, so that's my domain. My range, oh, this is kind of a hard one to do, range. My range, okay. So, for this one, this is a exponential graph. Hopefully you can tell by looking at the picture. Okay, so we're going to be going, it's this line, this arrow is going to continue this way forever, getting as close to hitting the x-axis, which is y equals 0, as possible, but never actually hitting it. All right, so let me think, how would I want to put this? So I guess we would do kind of the same thing. It's approaching 0, but it's never actually hitting it. And then how high do we go? The highest point we go is 1, but once again, it's a whole. So just like that. We never get higher than this, and we're never going to get below 0. We're never actually going to hit 0, right? This right here, if I had a point, let's say, put another one, 6, and I had a point there, that would be x is 6, y is 0, right? We know this. If it's on the x-axis, so like here or here or here or here, then it would be, so it'd be 3, 0, 4, 0. If it's on the x-axis, then y is equal to 0. Okay. Anyways, sidetrack. But we're never actually going to hit 0. This arrow is going to continue on getting smaller and smaller and smaller, like to like point. Like it'll get down to like 0.00000000001. And smaller than that. But it'll get so incredibly small, but it'll never actually hit. It'll never actually hit. Okay. Okay. So that was number 14. Oh wait, we only did domain range. What else do we need to do? I can't even remember. Oh, the max. Okay, well your maximum is, we're not actually hitting 1, but you're approaching. Can you still see this? Oh, just pull it down there. You're approaching 1. Right? You're not hitting 1, but you're approaching 1. Your minimum, once again, there is no minimum, but we're forever approaching 0. What else did I say? Domain, range, max, min. Oh, intercepts. So technically, because this is a hole, we're getting super close to the y-axis, but we're not actually intersecting it. Yes. And then x-intercept, nope, because this is going to travel forever and ever, but never actually touch it. So we have no intercepts. No intercepts. Okay.